There are places on Earth where time seems to slow down, where environmental conditions remain stable for very long periods, to the point that many species are not under pressure to change rapidly. In such ecosystems, biological characteristics are retained over generations, creating a chain of existence that lasts for millions of years. Amazon is one of the clearest examples. With an area of over 2.3 million square miles and a dense network of rivers, this ecosystem maintains stable temperature, humidity, and environmental structure, especially under the forest canopy where light is significantly limited. This continuity creates an environment where many survival strategies remain effective without needing to change. Under these conditions, many species have evolved to optimize energy, reducing movement, minimizing energy expenditure, and utilizing ambushes in confined spaces. These are not new behaviors, but strategies that have existed for a long time and continue to be maintained. As water flows towards lowlands, carrying sediment and reducing visibility, the environment becomes turbid and difficult to observe. It is in this space that ambush strategies become particularly effective, allowing large predators to continue maintaining their role in the ecosystem. As the water flowed away from the highlands and towards lower areas, the environment began to change. This led to Ilha de Marajo, a vast swamp at the mouth of the Amazon River, where the water was always murky, rich in sediment, and visibility was limited. The average depth was only about 1 to 3 feet, but it was precisely these shallow and stable conditions that persisted for a very long time, almost unchanged. In that environment, vision was no longer an advantage. Many species reduced their movement, conserved energy, and utilized enclosed spaces to control their surroundings. These are strategies that existed from very early times and continue to this day. Hidden beneath the murky water is one of its most obvious representatives, the green anaconda. It can be over 20 feet long and weigh around 500 pounds, but the important point isn't its size, but how it survives. Most of the time it lies motionless in the water, blending almost completely with the mud and vegetation. There are no obvious movements, no easily recognizable signals, yet it controls its surroundings. When another creature passes by, the reaction is almost instantaneous. There's no chase, just a brief, precise movement, using its entire body mass to control the situation in a split second. This strategy is a legacy from ancient species like Titanoboa, where large size wasn't for speed, but to optimize control within a confined environment. Its slow circadian rhythm allowed it to maintain this state for extended periods without constant energy expenditure. Its presence wasn't easily noticeable, but its impact was clear. Other species avoided shallow waters, altered their activity times, or moved to areas with higher cover. Over time, these changes became stable patterns repeated across generations. But to understand why many life forms in the Amazon have been able to survive almost unchanged for millions of years, we need to look back toward the boundary where the rainforest landscape is completely interrupted. Beelzebufo are one of the oldest groups of amphibians ever to appear on Earth, with an evolutionary history spanning approximately 200 to 250 million years, dating back to the time when primitive wetlands began to form in the global hot and humid climate. In that prehistoric ecosystem, they lived densely in shallow swamps where the water was still, the light was weak, and aquatic plants thrived, creating an environment that remained virtually unchanged over geological time. Their body structure clearly reflects this primitive characteristic. Thin, capillary-rich, and permeable skin allows for direct gas exchange with the environment, a survival mechanism from the early amphibians when life depended entirely on moisture and water stability. This characteristic makes them one of the first groups of organisms to adapt to the boundary between water and land. However, in these ancient ecosystems, frogs did not hold a dominant role, but rather became a stable source of bioenergy in the food chain, accessible, widely distributed, and entirely dependent on environmental conditions. Their existence reflects a world where evolution did not occur abruptly, but operated slowly in a balance that lasted for millions of years. All water eventually converges at Lake Mamidawa, a still body of water where the surface is almost motionless. The dark water reflects like a mirror, completely concealing what lies beneath. This is not stillness, but rather a place where two opposing biological strategies coexist in a confined space. The first species is the black crocodile. Its body is covered in hard, armored bone plates, forming a protective layer almost impervious to the surrounding environment. But its greatest advantage lies not in its armor, but in its ability to maintain a nearly immobile state for extended periods. It can lie still for days, without significantly expending energy, observing and memorizing the movement patterns of other species in the same area. When the right conditions arise, the reaction occurs almost instantaneously. There is no superfluous movement, no apparent preparation phase, just a brief moment where all the energy is unleashed. The bite force can reach around 3,700 pounds per square inch, enough to break through the hardest structures in shallow water. However, not every organism in these waters is susceptible to that strategy. Within these waters, the Arapaima appears as a living remnant of deep evolutionary time. Its lineage stretches back roughly 100 to 120 million years, to an era when prehistoric freshwater systems were unstable, oxygen levels fluctuated, and survival demanded adaptation to conditions that no longer exist in the same form today. What remains now is not a relic frozen in time, but a continuing branch of ancient biological history belonging to the order Osteoglossiformes. Its need to surface for air reflects that earlier world. It is not a modern innovation, but a survival response, shaped when water alone could not be relied upon to sustain life. In such conditions, existence depended on the ability to move between two environments, air and water, rather than be confined to one. Beneath the surface, its form carries the same prehistoric logic. It is not built for pursuit or dominance, but for endurance, an organism shaped in systems where stability over long periods mattered more than speed or aggression. Every structure serves continuity, allowing it to persist in environments that remain physically demanding even today. In the Amazon basin, these ancient conditions still persist in fragments: slow-moving currents, low visibility, and enclosed waterways that resemble the constraints of a far older Earth. Hidden deep within the ancient Amazon sediments are the traces of a ruler who once stood at the top of the entire freshwater ecosystem, Prehistoric. Approximately 8 to 5 million years ago, this giant crocodile could reach lengths of over 30 feet, with a skull large enough to crush almost any living organism in its environment. But what made Prehistoric special wasn't just its size, but its role in the ancient ecosystem. Absolute control of shallow waters, where every movement was limited by limited visibility and space. Unlike predators that relied on speed, Prehistoric survived on almost absolute patience. It could remain motionless for extended periods, blending into the murky water, waiting for the slightest signals from its surroundings. In such conditions, even a momentary lapse in concentration was enough to trigger this entire biological mechanism. And when that happened, the shallow water space was almost completely locked within its control. However, during the late Miocene, climate and river systems in South America began to shift. Water levels became more unstable, wetlands fragmented, and seasonal temperatures fluctuated more strongly. These changes reduced suitable habitat and prey availability for a predator adapted to consistent conditions. Its large body size, once an advantage, became a disadvantage in a more fragmented and resource-limited ecosystem. Combined with increasing competition from other emerging predators, Prehistoric gradually disappeared. Its extinction reflects a broader pattern. Highly specialized apex predators can dominate stable environments, but struggle when those conditions change beyond a critical limit. Deep within the Igapo wetlands, where ancient tree roots are submerged in year-round black water, the Amazon ecosystem begins to reveal unusual life forms. Here, dominance isn't about size, but about characteristics that originated far back in the past. The first species was the hoatzin. As a juvenile, it possessed distinct claws on its wings, allowing it to cling to and climb branches before it could fly. This is a rare feature in modern birds, but was common in ancient bird forms more than 100 million years ago, during the transition from reptiles to birds. Fossils like Archaeopteryx show that similar structures existed very early in evolutionary history. In most ecosystems, this trait disappears once the bird develops full flight. But in a stable environment like the Agapo, where stress changes are low, that structure is retained because it remains effective in its juvenile stage. Hoatzin is therefore not just a bird, but a biological form that still carries the direct imprint of tens of millions of years of evolutionary history. At the lower levels of the ecosystem, another adaptation emerges, the Paraponera clavata. This insect does not retain the ancient morphological features, but represents a prolonged evolutionary process towards specialization. Over time, it developed a potent neurotoxic venom system, which acts as an effective defense mechanism in the stable jungle environment. Within the same ecosystem, these two forms of existence reflect two different paths of evolution. One retains ancient structures from the past, while the other continuously optimizes to achieve a high level of specialization. Both can survive for long periods, but both depend on the same condition: environmental stability. When that condition is maintained, these characteristics persist through many generations. But when the environment changes, those once effective structures can become limiting factors. And that is a pattern that has repeated itself many times in evolutionary history.
Makes 4 wings.
The Amazon rainforest isn't a museum of fossilized skeletons lying dormant underground. It's a place where prehistory is still unfolding. Subscribe to the channel for the latest content on Amazonian prehistory. The existence of the anaconda, the black crocodile, and the arapaima proves a paradox. Evolution is sometimes superfluous if you have already reached a near-optimal biological design. But the stability of the past 55 million years is facing its greatest test yet: humanity. We are not just invading a forest, we are directly tearing apart the planet's last remaining pristine biological heritage. The journey to decipher the oases of time in the Amazon is far from over. The mysteries of ancient creatures and how they dominated the jungle will continue in subsequent episodes. What we know about the Amazon is only the surface. The ecosystems hidden deep within still hold many unsolved mysteries, and that journey continues.